Now that we are moving through exponential and logarithmic equations, what we're going to do now is we're going to combine those principles and being able to convert between exponential and logarithmic form to where we can start working with solving these equations when we have something that we really haven't encountered before, and that's having a variable in the exponent. So what we will do here is when we are working on these, we want to solve for when we're doing our equations, we're trying to find like bases, and we're just going to work with that for now because we know that 8 and 16 are going to be like bases. So solving this exponential equation, we have a common base and looking for a common base, and what is the solution. So we know that if I take 16, I know that 16 is technically 2 to the 4th, and I know 8 is 2 to the 3rd, so I can do some substitution. So I know that 16 to 3x equals 8, and I know then that 2 to the 4th I substitute in, and then of course I have 2 to the 3rd. I want to go ahead and simplify here. And I want to do these exponents in a power raised to a power. I do multiplication. So that is going to be 2 raised to the 12x equals 2 raised to the 3. And now we know that since our bases are common, we know that the exponents are going to be equal. So I have 12x is equal to 3. Divide both sides by not 3, but by 12. And then x is going to be equal to 1/4. There you go, there's your answer. And doing the same thing with the other equation, if you look at it, think about what my common variables are going to be, or my common x's, not x's, I'm sorry, what my common bases are going to be. And I know that both 27 and 8, so 27 is the same thing as 3 to the 3rd, and 81 is going to be the same as 3 to the 4th, so I can do some substitutions. And so this is going to be 3 to the 3rd times 3x, or up to 3x, and this is going to be 3 to the 4th. Go ahead and simplify. We get 3 to the 9x equals 3 to the 4th. And again, we know then that since our bases are equal, our exponents are going to be equal. So I have 9x is equal to 4, divide both sides by 9, and then x is going to be equal to 4 over 9. There you go. That's how we work with a common base to solve for exponential equations. And if we go here, let's look at what we have coming up. We have different bases. So now let's see what happens here. Now, since I can't look at both 15 and 285, and there's not going to be any common base that I can determine here, so what I can do is I can go ahead and just find the logarithm of both sides. So if I take the log, remember what we do to one side we must do to the other. 15 3x is going to be equal to the log of 285. So I've taken the log of both sides. And now I can start looking at some of my rules. I know that in doing that, I can use my power rule. So I have 3x times the log of 15 is going to be equal to the log of 285. And now, you know, we haven't really looked at this, but think about it as this is multiplication, 3x times the log of 15. Well, what is my inverse operation of multiplication is going to be division, because I'm always trying to isolate that variable right there. So I'm going to divide away that thing that's causing me the problem. I'm going to divide away the log of 15, and what I divide on one side, I must divide on the other. And now I know that that is going to cancel to 1, and I have 3x is equal to the log of 285 over the log of 15. And if I go ahead and divide both sides by 3 to further isolate my x, then that becomes that, or x becomes becomes the log of 285 divided by 3 log of 15. And that's what x is equal to. You can put that in the calculator, and you're going to find out that it is approximately 0.9623. So again, working with what they gave us, finding the log of both sides, and able to work that out to that decimal. Let's see, so this next one, if we do the same here, we convert shoot, how about we just take the log of both sides, right? What I do to one side, I must do to the other. There we go. So I have those logs. Well, since there were no common bases for 5 and 130, and now hopefully you recognize that you can do the power rule here and rewrite that. So we have 2x log of 5 is going to be equal to the log of 130. Again, trying to isolate the variable right there, so I'm going to divide away I can divide away all at one time 2 log of 5. And that will get this thing right here, my variable, all by itself. And if I divide the other side by 2 log of 5, then I know that what I was looking for is my log of 5 cancels out to 1, my 2's cancel out to 1. So then I'm just left with x equals the log of 130 over 2 log of 5. And there you have it. You have isolated your variable, and that is x. And if you put that into the calculator, x is going to be equal to approximately 0.738. Let's see, going with this next problem, solving exponential equation with a calculator. We've actually been doing that when we went ahead and put that log in there, but we can go ahead and do it here again. I know that there are going to be no common bases between 7 and 800, so I need to go ahead and write that, take the log of both sides. So I find the log of 7 to the 4x is equal to the log of 800. And we can do the power rule. So bring that 4x out front, and I'm going to have 4 log of 7, 4x log of 7. That looks like garbage. So I will try that again. 4x, the log of 7 is equal to the log of 800. Now I can go ahead and remember I'm trying to isolate my variable, so these are multiplication. So with multiplication I can go ahead and do division to counter that. So I'm going to divide away my 4 and my log of 7, and what I do on one side I must do on the other, and that is going to cancel out to 1, that is going to cancel out to 1. So I'm left with x equals the log of 800 over 4 log of 7, or x is equal to 0.6133, 6133. And there you have it. You have solved for your x value with a calculator, exponential equation. And let's see, let's shoot for B here. And not common, so I can go ahead and take the log of both sides, equals to the log of 400. Don't forget your power rule, right? Let's bring that exponent down. That's the whole reason we take a log of both sides. And I have 3x log of 5.2 is equal to the log of 400. And of course, what I need to what I need to isolate is my variable, so I want to divide both sides by 3, and then the log of 5.2. And now I've isolated my variable because my 3's will cancel out to 1, my log will cancel out to 1, and therefore I have x is equal to the log of 400 divided by 3 log of 5.2, which is going to equal, with a calculator, 0.6210. There you go. Solving exponential equations with and without a calculator. Okay, modeling with an exponential equation. Remember, we're looking for y equals a times b to the x. And a we know is my initial value, b is going to be some growth factor, and then x is going to be the variable or the time. So it says wood is sustainable, renewable natural resource when you manage forests properly. Your lumber company has 1,200,000 trees. They plan to harvest 7% of the trees each year. How many years will it take to harvest half of the trees? Okay, well, we know then that A is our initial point, so something is going to be equal to the starting value of our trees. And the rate is going to be 1 minus, and of course, we know that that should be the principal 1 minus RT. 1 minus, and they're harvesting 7%, so that's going to be 1 minus 7% each year for some amount of time. And, well, that some amount of time, how many years will it take to reach or to harvest half the trees? And half the trees is going to be 600,000. So looking at this, we have, let's see, what can we do? Before we do anything, we should be able to convert that 4% to a decimal. And so let's see here, 600 0.93 time. And now I can go ahead, when in doubt, just combine like terms. So I'm going to divide away this. I'm trying to isolate my variable, so moving anything I can away from that is going to be. And then therefore we get, this simplifies to 1/2 is equal to 0.93t. And now we are in a position where we can create that exponential equation by finding the log of both sides. So let's see here. Let's go over here, and I have the log of 1/2 is equal to the log of 0.93t. Looking at your power rules. And again, when we're working with equations, if you just keep calm and combine like terms, the things that you need to do next will reveal themselves. You just have to be patient and do what you know to do. Okay, and again, I'm trying to isolate my variable. And what I can do now is divide away the log of 0.93. And we know that that's going to cancel some stuff out. And then t is equal to the log of 1/2 over the log of 0.93, or t is equal to approximately, gosh, 1 second. All right, t is equal to, I think, 9.55. So you plan, how many years will it take to harvest that? So you get 9.55 years, or t could be approximately 10 years. It just depends on the answers the book might be looking for at the time. And let's see here, how many trees will have harvested the tree. After how many years will you have harvested half the trees at 5% instead of 7%? So we know that that is going to be 1/2 is equal to 0.95 raised to the t. So we have the log of 1/2 is equal to the log of 0.95t. Log of 1/2 is equal to t log of 0.95. And what did I do there? Real quick, I went ahead and I started off with, again, 101,200,000 trees divided by 600,000, or 600,000 divided by that is going to give me that 1/2. And I went ahead and did this rate value here of 1%, 100% minus 5% gave me 0.95 instead of our 0.93. So this t, just showing you where I went, what things I did there. Sorry. Log of 1/2 is equal to t log of 0.95. And then, of course, I'm going to divide the log of 0.95 away. And then t is going to be equal to the log of 1/2 over the log of 0.95, which happens to be equal to, heck, I don't know. So that equals 13.51, or approximately 14 years. Again, depending on what answer they're looking for. Let's see, solving a logarithmic equation. Let me see, what should we do here? Some things that we need to remember that when you have an equation and there is no base, then we know that that is base 10. Remember, that's base 10. So if we go and reorder these, we can reorder them, using our logarithmic functions. This should become, let's see, 4x minus 3 is equal to 10 raised to the 2, or the log of b to the x, and then we would reorder that to b raised to the y power is equal to x. So there you go, I've got my x value here. It is equal to my base, which is 10 raised to the y. So looks like 4x minus 3 is equal to 100. And then, of course, divide away your coefficient, and x is going to be equal to 103 divided by 4. There you go. Okay, again, reordering this into exponential form, we have 10 to the negative 1 is going to be equal to 3 minus 2x. Some things to consider here is this. This thing right here. That is actually 1 over 10. And go ahead and combine like terms. And simplifying that, that should be negative 30 over 10 plus 1 over 10. And then negative 2x is going to be equal to negative 29 over 10. And let's see here, if I divide both sides by 2, then x is going to be equal to negative 29 over 20. There you go. We've just found that logarithmic equation. All right, using logarithmic properties to solve. Well, this is going to be a challenge for me because I have two different logarithms there, but I do know that I can bring them back together as a single log. And since I'm going to reverse this and go from an expanded term to a single term, I know that this plus sign is indicating multiplication. And I do have like bases, so I should be able to rewrite this as the log of x minus 3 times x is equal to 1, because I've just gone and made that into a single expression, or the log of, I'm going to FOIL this out here, x squared minus 3x is equal to 1. is equal to 1, and then if I do my reordering here, I know that x squared minus 3x is going to be equal to 10 to the first, or 10. And now in order to combine like terms, go ahead and subtract 10 from both sides. And what I'm doing now is I'm trying to get to that standard form of a quadratic equation right here. So in doing so, I'm going to have x squared minus 3x minus 10 is going to be equal to 0. And I think I can factor that now. And I know that when I factor that, I'm going to have x minus 5, x plus 2, and then using my zero product property, x minus 5 is equal to 0, x plus 2 is equal to 0, or x is negative 2 and x is 5, or x is 5 and x is negative 2. You can put those back in the equations and check them, and you'll find out that they both work. So there's your solution to A. And then B would be, feel free to take a moment to work it out yourself. Really take a moment to work it out yourself. Go ahead and pause it. Some things to look at are going to be the quotient rule, right? Since we have both of them are base 10 and you have the subtraction, then it's going to be quotient rule. And hopefully you've given it a chance, but let's see here. Hopefully you've already tried. We're going to have the log of 6 over 3x, because of the quotient rule, is equal to negative 2, or the log of 2 over x is equal to negative 2. Now we can go ahead and do our convert it into an exponential equation, and that would be 2 divided by x is going to be equal to negative 2, is going to be equal to 10 to the negative 2. And let's see, what does that going to equal for us? All right, so 2x is equal to 1 over 100. That's what 10 to the negative 2 power is. And now if I do some cross multiplication, I know that x is going to be equal to 200. Cross multiplication, I multiplied x and 1 and then 2 and 100. And there you have it. I've done the equations, found the logarithm of both sides, combined like terms, zero product property, and of course cross multiplying. So again, just working through the equation with the steps you know and the steps you've learned, always falling back on the properties of the quotient rule, the product rule, the power rule. It's going to get easier as you work each problem. So let's see, again, give me 5 problems. Each one of them will get easier. By the 5th one, you're probably going to have a lot more confidence and ready to keep going.